And we're back, and still better than ever, still in 14-2, the gas laws. In this podcast, we're just going to simply wrap up our discussion with the gas laws, talking about Avogadro's law, and then I'm also going to mention what's called the combined gas law, simply because it will be in every textbook. However, I'm going to show you a different way to solve questions other than using that combined gas law. But let's go ahead and jump into Avogadro's law, which is the relationship between the amount of a gas, the number of moles, and the volume. And it's simply this: the volume is going to be directly related to the number of particles or the number of moles by some constant. I'll just use D. Or of course you could rearrange this to say the volume over the number of moles will remain constant. Now in this case, we just have a simple diagram that shows the effects of increasing the number of particles, and it's simply this. As you increase the number of particles in a container, the volume is going to increase until it matches the original pressure. Now, you've experienced this by blowing up a balloon. The more air you put into a balloon, the bigger it expands, or the more volume that it's going to have. Now, why is this? Again, let's go ahead and scroll down to the reasoning. It's simply this: if you increase the number of moles, N, the more particles you have, you simply have more collisions. The more collisions that you have, the greater the pressure that's exerted on the container wall. And if the container wall is allowed to expand, it's going to press out and increase the volume. And if it increases the volume, the pressure will decrease back to the original pressure. So if we simply say that we don't mistake this for disproving Boyle's law, an increase in pressure does not cause an increase in volume. As you increase the volume, the pressure will return back to its original. Now on the flip side of this, if you lower the number of moles, you're going to have fewer collisions. If you have fewer collisions, it's going to decrease the internal pressure, and as that internal pressure decreases, the outside presses down and presses in and will squeeze the volume, and that volume will decrease. Now again, as this volume decreases, the pressure itself will increase back to the original pressure. So the pressure here is really not changing overall. It is simply adjusting with the volume. Okay, but the basic idea is simply blowing up a balloon, and as you increase the number of particles that you put in the balloon, it's going to expand. As you let the particles out of the balloon, it's going to shrink in volume. Now the last thing we want to talk about in this section is what's called the combined gas law. I'm simply going to write it down. Most textbooks are going to show you that the original pressure times the volume divided by the temperature is going to equal a final pressure times the volume divided by the temperature. So we have P1 V1 over T1 equals P2 V2 over T2. The reason why I'm going to show you something different is that we are going to solve all gas law questions with what's in 14-3, which is called the ideal gas law. Okay? And we'll take a look at that in the next podcast. We'll see you next time.